All right, let's do problem 13.6. Here we have, they say, an isosceles triangle, which means two sides the same, x and x. Call the bottom y. The perimeter is 12. If the perimeter is 12, that means x plus y equals 12, or y is 12 minus both those x's. Okay, so we can write that here. Y is 12 minus 2x. Now for part A, they want us to find a function, and they call it little a for area. I usually use capital A, but whatever. That our area, they want to find the area of the triangle is a function of x. It's a triangle, so we know the area of a triangle is 1/2 base times height. The height's easy. The base is easy. That's 12 minus 2x. But the height we're going to have to figure out. So there's our height. Right away, of course, we can see it's a right triangle. So, and they're the same on both sides, so I can do this. So we know that the hypotenuse, which is x squared is equal to h squared, which is the height, plus half of the base squared, right? Because half of the base is 12 minus 2x, so half of that is what, 6 minus x? 6 minus x squared? Half of the base, half of 12 minus 2x, that looks right. We want h, so h squared is equal to x squared minus 6 minus x squared. So I'm going to square that out, so minus 36 plus x squared minus 12x, right? 2 times and multiply together, minus 6x minus 12, that looks right. Or h is equal to the square root. And let's see, x squared minus x squared, that's really nice. The x squareds go away. We have 12x minus negative 12x is positive 12x minus 36. So it's nice to put positive 1 first. Let's see, each of those has a 4 in it. So that's equal to the square root of 4 times 3x minus 9. Square root of 4 is 2. So that's 2 square roots of 3x minus 9. Okay, so now we can write what our area is. So the area, A, they're calling it little a, as a function of x, is 1/2 times the base, which is 12 minus 2x, times the height, which we just figured out, which is 2 square roots of 3x minus 9. The 2's cancel, 2 and the 1/2 cancel, that's always nice. So finally, our area as a function of x is 12 minus 2x times square root of 3x minus 9. We can see that x has to be at least as big as 3. Can't be less than 3 or we have a square root of a negative number. So the domain, x has to be greater than or equal to 3. And if x was 6, we just look at our picture, if x was 6, we have 6 plus 6, we have no room left for a base because the perimeter is 12, right? If we take up all the perimeter for x, we basically have 0 base, which makes it not really a triangle. I don't know if you call it a triangle with no area, but it would have 0 area then if x was 6, and we can see that here. If x was 6, 12 minus 6 is 0. X can be 6 in here, but it can't be 6 there, or we have area of 0. So, which makes sense. There's no room for the base, and if x was 3, then the base would be 3, have to be 6, and again it would be like a flat triangle, which is that a triangle not? I don't know. But anyway, that's the domain. X goes there. All right, now part B says assume the maximum function of the domain occurs when x equals 4. So they're telling us that when x is 4, we get the biggest area. The area is biggest when x equals 4. They just say, figure that out. It makes sense. We could graph it and see that's the case. So the biggest area is 4. So what is that area then? So let's plug in 4. So a at 4 is 12 minus 2 times 4 times the square root of 3 times 4 minus 9. See, that's 12 minus 8, so that's 12 minus 8, so that's 4 times square root of 12 minus 9, so 4 roots of 3. So that's the biggest area we could possibly have is 4 roots of 3. Okay, now they're going to be mean to us and say, okay, how about this function that they just made up, because that's what we're supposed to be learning this chapter. what's 2 times the area of a new variable x, which is 3x plus 3 plus 1. So what's the maximum value of this? Well, the maximum value of A, of the area, no matter what's in the inside, no matter how we to make a new x here, right, doesn't matter. The biggest A can be is 4 roots of 3. So the biggest this can be then is 2 times 4 roots of 3, and then we add 1 to that, so that's 8 root 3 plus 1. That's the biggest this z can be. Okay, that's not so bad. Now in part C, they graphed A for us. They graphed this function, and this is what you get. They're nice, and they graph this function here. And this peak here, I made that wrong. This peak here is 4 square roots of 3, right? That's A. This happens at y equals 4 roots of 3. This point here is 3, 0. When x equals 3, the biggest it can be is 6, 0. Area is 0, area is 0. Here's our biggest area. Now they're saying, okay, so what is this new thing? We're 2a 3x plus 3 plus 1. So now we have to modify this by doing these operations to it. Okay, so we have this new function z, 2a of 3x plus 3 plus 1. Okay, the first step, we got to get x by itself. So this is 2 times a of 3 times x plus 1, and we check our work. 3x is 3x, 3 times 1 is plus 3. Looks right. So this is our z. So what are the steps? How do we go from a to this? From our regular old a to what do we do to here? So the first step you always do is you dilate in the x direction. So that's the 3 there, because it's inside the a. So it's dilating the x direction, which means that it's compressing. It's 3 times smaller. If you multiply by 3, the x by 3 makes it 3 times smaller, which means multiplying by 1/3. Either way you want to look at it. Then you shift. Second step is you shift in the x direction. Plus 1 is always the opposite. You shift to the left one. The x ones are always opposite. Then we go in the y, which is the 2 here. Now the y, it makes sense. That 2 dilates. You always dilate in x, or dilate in the y direction 2, which makes it bigger in the y direction by 2. And then finally in the y direction we add 1, so we shifted up 1. The y directions always make sense. The x directions are opposite. So we dilate it by 2 in the x direction, compress it by 3 in the dilate it by 2 in the y direction, compress it by 3 in the x direction. Okay, so those are 4 steps. So what we got to do is take our old graph, this graph here, and do those 4 steps to it, which is pretty hard to do on just taking a graph and trying to compress it. But we can take the 3 main points and do it to the points and then plot the new points on a new graph. So I'm going to take these 3 points, 3, 0, 4, 4 root 3, 6, 0, and then do all of our work on those. So let's write the points down first. So 3, 0, 4, 4 root 3, and then 6, 0. Then we're going to do these 4 operations on them and then plot the new points. Okay, my voice is going away. First operation, compress it by 3 in the x direction. Divide the x value by 3. So 3 divided by 3 is 1. That's easy math. 4 divided by 3 is 4/3. The y's stay the same. 6 divided by 3 is 2. Y's stay the same. Then take away 1 from the x. 1 minus 1 is 0. That's our second step. 4/3 minus 1 is 1/3. Again, y stay the same. 2 minus 1 is 1. Y stay the same. Okay. Excuse me. Third step. Multiply the y by 2. Make the y 2 bigger. X's stay the same. So 0 times 0 is still 0. X is the same, 1/3, multiply that by 2, that's 8 root 3. X stay the same, multiply the y by 2, that's 1 comma, and what did I do here? You guys aren't around to stop me. This was 2, 0, step 2, we shifted to y1. This was a 0, not 4 root 3. Hopefully you guys caught that at least. Okay, so multiply this by 2 and we still get 0. So 1 comma 0. And finally, we add 1 to the y. So our fourth step, we add 1 to the y. So it's 0 comma 1, 1/3 comma 8 root 3 plus 1, which you will notice is our maximum value, of which we already figured out in part B. And we could have just done this to figure it out. And we add 1, so it's 1 comma 1. So those are our new points for the new graph. So all we got to do to graph it now is look on our old graph, and I'm just going to do it on top of this one, and we have the points, these points right here. So 0 comma 1, which is x equals 0, 1, so that's about right there. And then 1 comma 1, so 1 is right there, so it's right here. And the middle one is 1/3 and 8 root 3 plus 1, which is pretty big. That's somewhere around 15, I think. So that's just going to be way off the charts here. So that's 1/3, x equals 1/3, which is right about there, and it goes way up to here, somewhere around 15. And so the graph looks like this. It goes up to that big thing. It's really skinny and comes down to there. And clearly from the graph, we see the domain of this function is from 0 to 1. Right? The x's go from 0 to 1. We could see that from our points. The x's go from 0 to 1. So the domain, writing it in this form, is 0 to 1. And we can see that the range goes from y equal 1 all the way up to our max value, which is 8 root 3 plus 1. So the range goes from 1, the y values go from 1 all the way up to here, then they go back to 1, so 1 to 8 root 3 plus 1. So by graphing it, and doing all this operations, graphing it, it's pretty easy to get the domain and range. All right, hopefully that makes sense, and these things are making sense to you. Thanks for watching.